Let us try to learn the formula for total number of reflexive relation of a set containing n elements. Okay. The formula is this: 2 raised to the power n square minus n, that is n into n minus 1. Now how does it happen? Let us discuss. Let us discuss it for a set containing only two elements. Okay, means here n is 2. Then if you do it practically, then you can say that A cross A will have the members as 1 1, 1 2, and 2 1, 2 2, isn't it? So reflexive relations will be one set which is containing 1 1, 2 2. This must be there. Another, it is possible that 1 1 is there and 2 2 must be there, and one extra member 1 2 is coming over here. Another possibility is 1 1 is there, 2 2 must be there, 1 1 and 2 2 must be there. Another element which is there is 2 1 is there, and one more possibility is there: 1 1, 2 2, and 1 2 and 2 1. Do you agree? So altogether, how many reflexive relations are there? 4. Yes, therefore 4 reflexive relations possible in case of set with two elements. Now if you go through this formula where n is 2, then according to that 2 raised to the power n square minus n, that is 2 raised to the power 2 square minus 2, that is 2, 4 minus 2, that is 2 power 2, and that is 4. Okay, same will be true for the set containing 3 elements, the same formula. Now how we have got this formula? How we are attaining to this formula? Let us learn about that. Means suppose you have n elements over here. Okay, a set A is having n elements, 2, 3, dash dash dash, n elements. What happens then? Then A cross A will have 1 1, 1 2, 1 n. Okay, then 2 1, 2 2, 2 n. Okay, similarly 3 1, 3 2, dash dash dash, and 3n. I'm not going to writing anymore. We will come to here, then n1, n2, dash dash dash, nn. Okay, so altogether A cross A is having how many elements? How many elements are there in A cross A set? N into n, yes or no? N into n elements means n square. Altogether you have n square elements in your A cross A. Out of that, if you go through this, the diagonal elements, this is your 1, this is your 2, here it will come to your 3. I should write 3 also, 3 3, yes. So if you move on diagonally and you will reach here. Okay, so these elements are what? These are the elements which make your relations reflexive, yes or no? Agreed? These are the basic elements to be a relation reflexive. Okay, what are the other members possible for this set? Now, from the number of elements, it is very much clear that every reflexive set must have to contain these many elements. Remaining elements. How many remaining elements are there? N square is the total elements, and n elements are in the diagonal, which must be there. So remaining elements are n square minus n elements. Then this n square minus n elements may be there, may not be there. Means these many elements have two choices. How many choices they are having? Two choices. That is why your total number of reflexive relations comes as 2 raised to the power n square minus n. Have you understood this? This is the reason. So now just come here to the back. So every this is called, this is the diagonal elements. What is the name? It is diagonal elements. Okay. So these are the basic form of the reflexive relations. These elements must be there in the relations. You can also say it that these elements who are in the diagonal form means 1, 1, 2, 2, 3, 3, and n and so on. All these elements have only one choice, that they must be there. So there are n elements in the diagonal. So you have each of those n elements have how many choices? Only one choices. So 2 2 is also having only one choices. 3 3 is also having only one choices. Okay, one choices. Up to how many? Up to 1, up to n times. Okay, then and the remaining elements which I have told you, if you will leave the diagonal elements, how many elements are left here? Diagonal elements I should write n. Okay, so remaining elements are how many? You can find out now. Total elements are n square. So remaining elements will be n square minus n. So the remaining n square minus n elements, each of them will have how many choices? Two choices, to be there, not to be there. So 2 into 2 into dash 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 into 2 up to n square minus n times, and this product will give you 1 power n into 2 power n square minus n, that is 2 power n square minus n. Either this form you remember or you remember this way. So this will be the total number of reflexive relations. What is this? This is the total number of reflexive relations. Total number of reflexive relations. Okay, clear? So if you will have your set is having suppose 1, 2, and 3 elements, means 3 elements. So total number of reflexive relations will be how much? 2, 3, and 3 minus 1, that is 2 into 3 into 2, that is 2 power 6. Whatever is the calculation, you write it, and if you will separately you can make it. You can see also that these many relations will be 2 to the 4 to the 8 to the 16 to the 32 to the 64. So 64 number of reflexive relation will be there. Clear? In the next video, I will say the formula for the total number of symmetric relations. Okay. Thank you.